Jai Hind, I Vishwas Mishra, representing Swami Vivekanand Subharti University, presenting a lecture on electronic exchange, telephone traffic, engineering and digital switching. In this, we will discuss evolution of telecommunication, advantage of electronic exchange over electromechanical exchange, basic concepts of telephone traffic engineering, grade of service, scanning methods, basic principle of electronic exchange, bulk schematic of PC exchange, digital switching, time and space switching, and so on. In introduction, to overcome the limitation of manual switching, automatic exchange have electromechanical component were developed. Though it improved upon the performance of manual exchange, it still had a number of disadvantages. The crossbar exchange improved over many shortcomings of the Strover system. A number of moving parts in register, marker, translator, etc. were replaced and blocked by a single computer. Evolution of telecommunication. The first electronic exchange employing space division switching was commissioned in 1965 at New Jersey. Further research resulted in development of time division switching, which enabled sharing a single path by several calls, though providing full availability. The first digital exchange was commissioned in 1970 in France. The telecommunication system is an important and integral part of modern society. In addition to public switched telephone network PSTN, the switching system provides various services to the subscriber. Here, advantage of electronic exchange over electromechanical exchange. Electronic exchange category analysis, routing, translation, etc. done by relay. In electromechanical exchange, translation, speech path, sub facilities, etc. managed by MAP and other data. Any change in facility require additional of hardware or large amount of wiring, but in electromechanical exchange, changes can be carried out by simple command. Testing is done manually, externally and in time consuming, but in electromechanical exchange, testing carried out periodically, automatically and analyzed printed out. Partially full availability, hence blocking limited facility to the subscriber, but in electromechanical exchange, full availability, hence no blocking, a large number of different type of services possible very easily. Basic concepts of telephone traffic engineering. Telephone traffic is originated by the individual need of different subscriber, and so it is beyond the control of telephone administration. Any and every subscriber can originate a call at any and every moment without giving any previous information. In some localities, the traffic has seasonal characteristics. For example, at a holiday resort, a typical 24-hour variation in calling rate is shown behavior. However, by the nature of variation of traffic, telephone engineer is interested in maximum traffic that occur in an exchange, but busy hour traffic is the average value of maximum traffic in the busy hour. In computing busy hour traffic, the seasonal effects are also taken into account. When the volume of traffic is quoted in terms of number of calls originated in given time, this is insufficient to determine the consequent occupancy of line and equipment. The duration during which equipment and circuit are held when a call is made is called holding time. Measurement of telephone traffic. The total cost of providing telephone services can be roughly divided into these charges, which are constant and independent of volume of traffic, and those which are determined by the amount of traffic. The cost of subscriber line and instrument and certain individual equipments in the exchange is totally independent of the volume of traffic. The certain purpose it is sufficient to specify a traffic volume which is product of number of call occurred during the time concerned by their average duration. Traffic intensity is the average number of call simultaneously intensity of a long process. The average traffic intensity during a specified period T carried by a group of circuit or equipment is given by the sum of the holding time divided by T, the holding time and the period T all being expressed in the same unit. Grade of services. Owing to the fact that call originate in a pure chance manner, it is likely that during the busy hour some call may fail to mature due to insufficient of switching equipment. To ensure that the number of calls so lost is reasonably small, it is the standard practice switching equipment such that on the average not more than one call out of every 500 in the busy hour is lost at each switching stage. Scanning method. This is the practical method for measuring traffic in SPC switches. Here the observation of traffic is not continuous. The group of equipments are scanned at regular interval and the traffic flow is calculated. The formula is given. The quantitative indicators for quality of services. The quality of services of a telecommunication network is characterized by the level of satisfaction of the customer connected to it. The technical performance indicator encompass reliability, connectivity, and operator response time for booking calls. Specific technical performance indicators are fault rate, average number of line faulty any day as percentage of total main line, percentage of faults cleared by next working day, dial tone delay, call completion rate, time to answer for operator services. The basic principle of electronic exchange. The prime purpose of an exchange is to provide a temporary path for stimulation bidirectional transmission of speech between subscriber line connected to same exchange subscriber line and trunk to other exchange subscriber line and trunks for the other exchanges, pair of trunks towards different exchanges. These are also called the switching function of an exchange and are implemented through the equipment called the switching network. An exchange which can set up just the first three type of connection is called a subscriber or local exchange. If an exchange can set up only the four type of connection, it is called a transit or transcendent exchange. Sorted program controlled exchange. Modern digital computers use the sorted program concept. Here a program or a set of instructions to the computer is stored in its memory and the instructions are executed automatically one by the processor, carrying out the exchange control function through program stored in the memory of a computer to the nomenclature stored program control SPC. Introducing a computer to carry out the control function of a telephone exchange is not as simple as using a computer for specific or communicable data processing. A telephone exchange must operate without interruption 24 hours a day, 365 days a year and for say 30 to 40 years. This means that the computer controlling the exchange must be highly tolerant to faults. Fault tolerance feature can unknown to early computers, and the switching engineers were faced with the task of developing fault-tolerant hardware and software systems. The two types of space division switching system, one using electromechanical switching network and other using electronic switching network, are displayed in figure. Both the type qualify an electronic switching system, although only one of them is fully electronic. With the evolution of time division switching which is done in the electronic domain. Modern exchange can fully electronic. Block schematic of SPC exchange. In this, we have signal distributor, processor, scanner, maintenance console, memory, secondary storage cell, recording, programming and storage, etc. Centralized control exchange have all the control equipment is replaced by a single processor, which must be quite powerful. A centralized SPC configuration may use more than one processor for redundancy purpose. Each processor has access to all the exchange resources like scanner and distribution point and is capable for executing all the control function. Architecture may be configured to operate in one of the three modes: standby mode, synchronous duplex mode, load sharing mode. Standby mode. Standby mode of operation is the simplest of dual processor configuration operation. Normally one processor is active and the other is on standby, both hardware and software wise. The standby processor is brought online only when the active processor fails. An important requirement for this configuration is the ability of the standby processor to reconstitute the state of exchange system when it takes over the control. Figure shows a standby dual processor configuration with a common breakup storage. The shared secondary storage need to be duplicated and simple unit level redundancy could suffix. Synchronous duplex mode. In synchronous duplex mode of operation, hardware coupling is provided between the two processors which execute the same set of instructions and compare the result continuously. If a mismatching occurs, the faulty processor is identified and taken out of service within a few milliseconds. When the system is operating normally, the two processors have the same data in their memory at all times and simultaneously receive all information from the exchange environment. In figure, if a fault is detected by a comparator, the two processors P1 and P2 are decoupled and a checkout program is run independently on each of the machine to determine which one is faulty. Load sharing mode. In load sharing operation, an incoming call is assigned randomly or in a predetermined order to one of the processor, which then handles the call right through completion. Thus, both the processors are active simultaneously and share the load and the resources dynamically. Since the calls are handled independently by the processor, they have separate memory for storing temporary call data. Although program and semi-permanent data can be shared, they can kept its separate memory for redundancy purpose. Figure shows a hardware exclusion device which, when set by one of processor, prohibits access to a particular resource by the other processor until it is reset by the first processor. Conclusions. The electronic exchange work on a principle of stored program control. All the call processing functions are performed on the basis of pre-designed program which is stored in the memory of a central processor. Although the initially designed electronic exchange had single centralized processor, the control is being decentralized, providing dedicated microprocessor controlled subsystem for improved efficiency and security of the system. Digital switching. A digital switching system is one in which signals are switched in digital form. These signals may represent speech or data. The digital signal of several speech samples are time multiplexed on a common media before being switched through the system. To connect any two subscribers, it is necessary to interconnect the time slot of the two speech samples, which may be one, same or different PCM highways. The digitalized speech samples are switched into two modes via time switching and space switching. These time division multiplex digital switching system is popularly known as digital switching system. Time and space switching. Digital switching are not designed to handle signals of various states having multiple numbers. Analog switches are situated are suitable for representing multiple state signal. Time switching. In time switching, any input 8-bit pulse code modulation is allowed to forward to any output time slot. In this type, the input PCM word is written in the switch data memory and then read out as per the requested call. Space switching. In space switching, an 8-bit PCM word holds its time slot here as the original time slot remains the same during and after switching. It does not cause any delay. Digital space switching. A switching transfers signal from one input port to an appropriate output. A basic problem is then how to transfer traffic to a correct output port. Is the early telephone network operator closed circuit manually? Switching is all about the movement of traffic from one part of network to another. Switching system connect end system to switches and switches to other system. The usual connection that a digital switching system is required to establish are line-to-line connection, line-to-trunk connection, trunk-to-line connection, trunk-to-trunk connection. Digital time switching. Digital time switches can be used for a control of lighting, heating, watering of garden in both residential and commercial application where it is necessary to program the operation according to a weekly schedule. D-line is ABB range of digital time switches. An exclusive design featuring a black lit white LCD display plus extremely simple use with 2-line text menu and only 4 push buttons make the D-line products idea for automating the function of the installation. Main benefits: vast choice of program, protection against unauthorized access, high contrast LCD monitor for excellent visibility in all conditions, clear display for each contact status, easily manage vacation period. Main features: accessories such as DCF77 and GPS antenna, channel extension, software and programming key are also available. Reliability: equipped with large capacity internal batteries so they are able to function during a blackout or blackout. Date and hour setting are also maintained even during a power failure. Automatic summer winter time switch over. Thank you. Jai Hind.